Okay, so we're starting Pythagorean theorem number 2, and a couple of things to take mention. There are some problems that are new based on the new unit, and there are some problems that are old based on the previous unit. And there's just ways for you to get more practice, whether we're talking about the new or the old. So the first thing says, use the pictures below to write definitions for each vocabulary word. As a reminder, last week I said we're going to talk more about what Pythagorean theorem means. And I want you to take a look at these visuals, and I will need some help from the audience. Take a look at this triangle, the right triangle right here, the first one. Notice how it's called leg, leg, hypotenuse. The second right triangle, there's a leg, leg, and hypotenuse. And then this third triangle says there's no hypotenuse or legs because it is not a right triangle. Based on these three triangles, how might we define what hypotenuse or leg means?
Hypothesis is the long part of
Keep
it.
going.
Is it the long part of the shape, right?
What shape are we looking at specifically?
Triangles.
Yeah, so the hypotenuse is the longest side of a right triangle. What about legs? Could I get a volunteer to share out what they think legs are? What do they represent? So Milky said the hypotenuse is the longest side of the right triangle. What about legs? How do they compare?
They're the two other short sides.
Yeah, that's basically it. It's the two smaller sides of a right triangle. Okay. And this one does not have legs or hypotenuse because it is not a right triangle. And you can tell if it's a right triangle if there's a right angle. And a right angle is when an angle equals exactly to 90 degrees. And that's the shape of an L. So shape of an L right here, shape of an L over here. There's no L shape on this last triangle. So it's not 90-degree triangle. So let's see. I don't know if I can annotate on this document. I'll just share my screen using a whiteboard.
So it's just a shape with no calculations on it or of length or size.
I'm going to write the definitions on the whiteboard right now to give you a better, more formal. So I think the first word was, so we're talking about the Pythagorean theorem. And the Pythagorean theorem, we look at the hypotenuse, which is defined as the largest side of a right triangle. And the legs are two smallest sides of a right triangle. I'll go back to the screen shortly, but there's also another key feature about the hypotenuse. And if you look at where the right angle is, and you look at where the right angle is in the second triangle, the hypotenuse is always opposite. So where the right angle is, look directly on the opposite or across the right angle, and you'll find where the hypotenuse is. Once again, if you look directly across or opposite the right angle, you'll find where the hypotenuse is. So the other part of the definition, looks like I can't add onto it, is the following. Hypotenuse is always across, opposite the right angle. So let's get some practice, and this relates to problem number 2, where I'll be drawing some right triangles, and I want you to help me out and determine where the legs are and where the hypotenuse is. Okay. So remember, the hypotenuse is the largest side of a right triangle, and it's always across the right angle. And the legs are the two smallest sides of a right triangle. So I'm going to label all these. Please do not write on the board yet. Can you erase that? Thank you. 1, 2, 3. And then we have 1, 2, 3. Could I get a volunteer to share out number 1? So I'll label these. Let's call this A, triangle A, triangle B, and right triangle C. Could I get a volunteer for right triangle A? Which numbers are the legs and which number is the hypotenuse based on this drawing? If you could unmute yourself and just share it out loud.
Is it a leg?
Say that again. Which numbers are the legs for the pink triangle and which one is the hypotenuse?
2 is the hypothesis,
It's the
and
hypotenuse, right? Mhm.
yeah, and 1 and 3 is the legs.
How did you figure that out, Milky?
Because if the square is over here, it's the hypothesis is always on the opposite side of it,
Yeah,
and the 2 other ones are the legs.
yes. So right across from the right angle is the hypotenuse. So I'll draw a little arrow to point to the hypotenuse. And the other two sides are called the legs, and we can call this leg 1 and leg 2. Thank you, Milky. Could I get another volunteer to share out triangle B? Which numbers are the legs? Which numbers hypotenuse? And new volunteer.
1 and 3 are the legs, 2 is the hypotenuse.
Yes, hypotenuse. How did you figure that was the hypotenuse and the 1 and 3 other legs?
Hypotenuse is the opposite side of the right angle,
Right.
and then the leg next to the right angle.
Yeah, so the legs are next to the right angles also. That's another way to think of it. Okay. And it doesn't matter what you call it, leg 1 for number 1 or leg 2 for number 1. It doesn't make a difference. They're just both legs. They can be switched around. This can be leg 1 or leg 2. And this could be leg 1 or leg 2. And if I can get a third volunteer for C, new volunteer, which are my legs, which is my hypotenuse? If you can speak out loud. I'm not checking the chat if you can speak out loud.
1 is the hypotenuse, and then 2 and 3 is the legs.
And how did you figure that out? Kelly, right?
Yeah,
How did you figure that out?
because the 3 and 2 are the smallest sides, and then hypotenuse is the longest.
Yes, great reasoning. So I really liked how, let me write these people's names down on here. So I like how you guys all gave a different reason, and I really liked how you guys gave your different reasons. So Milky said the hypotenuse is across from the right angle, and that's how she determined the hypotenuse. And then Depankar said he figured out the legs by looking at what's next to the right angle. These two legs are right next to the right angle, therefore they're the legs. And then I liked how Kelly said that the two shortest sides are the legs, and the longest side is the hypotenuse. So those are just different ways to think about hypotenuse and legs. Are there any questions? This relates to problem 2 on your worksheet, identifying the legs and the hypotenuse. I also recognize that I forgot to say one more thing on the number 1, which is the Pythagorean theorem formula. So let me write it up here. And let's make this black. So the Pythagorean theorem can be interpreted using one of two formulas. And they mean the same thing, it's just different ways of writing it. So Pythagorean theorem. Sometimes you hear me say this like PT, Pythagorean theorem, just to abbreviate it. So one of the formulas is leg. I think I'm going to handwrite this because it's a little tricky to type it up. So one of the formulas can be seen as leg 1 squared plus leg 2 squared equals the hypotenuse squared. So what that looks like is leg 1, the square of it, and leg 2, the square of it. When you add these two squares up, so for number 1 and number 3, you get the hypotenuse squared. And that applies to the second one also. So leg 1, take the square of it, and you take the second leg, and you take the square of it. And when you add these two squares up, it equals the hypotenuse's square. Another way to interpret this, and this is what you'll find in textbooks and formula sheets, is a squared plus b squared equals c squared. A and b in this case are the legs, and c is the hypotenuse. So you take a squared, which is number 2, that's one of the legs, and you take b squared, which is the other leg, and that equals c squared, which equals the hypotenuse. Are there any questions about these two formulas? They mean exactly the same thing. If you have a question, just please unmute yourself. Okay, so I'm about to erase the whiteboard, and so I'm gonna clear that out, and then we're gonna go on to number 3. So I'm gonna do some examples for number 3. So let's say I have this triangle right here, and it says 12 as one of the sides and 9 as the other side. Then we'll create another problem. No, let's do one problem at a time. So what do we call 12? What do we call 9? And what do we call this side? What do we call each of these sides?
You call 12 and 9 the legs.
Mm-hmm. Yep.
Call the other side the, what's that called?
Hypotenuse.
Yeah.
I'm going to spell that out so you can learn how to pronounce it. It's a long word. So hypotenuse, which is actually the word of the week. So you want to write that down. Hypotenuse is the word of the week. This is how you pronounce it. And hypotenuse. Okay. Hypotenuse. So we know that leg 1 is, let me change colors and let's make this, oops, let's make that blue. So hypotenuse is blue. And if we want to use the formula correctly, we are going to use leg 1 squared plus leg 2 squared equals to our hypotenuse squared. So we draw the square. This side is 12. This side is 12. So what is the area of the square?
144.
Yeah, 144. So let me rewrite that. So this was originally 12. And we get an area of the square being 144. And then for the second one, we would have our squares of 9 times 9, and the area of the square would be 81. So if you want to write out the work, we have 12 squared plus 9 squared equals hypotenuse squared. 12 squared is 140. Whoops, wrong color. 12 squared is 144. 9 squared is 81 equals our hypotenuse squared. So 144 plus 81 ends up being 225, which equals our hypotenuse squared. So this whole thing, whoops, let's redo. This whole square area is 225, but we want to figure out what one of these sides equals. So earlier you recognized that we have 12 times 12 is 144. And we want to go backwards. So we need to go backwards. We have to take the square root. And to take the square root, the symbol looks like this. So we take the square root of the hypotenuse squared, and we take the square root of 225 to figure out what each of these sides is equal to. And the square root of 225 is equal to 15. Because 15 times 15 is equal to 225. That's the same thing when you look at the 144. Square root of 144 is 12, because 12 times 12 is 144. Square root of 81 is 9, because 9 times 9 is 81. And the square root of 225 is 15, because 15 times 15 is 225.
Mr. Hall.
Yes.
I understand how to do everything, but until you get to the part where you do 144 plus 81 equals 8 squared, right? And then you go 225.
Mm-hmm.
And then when you have to what's it called?
Solve for the hypotenuse.
Yeah, to divide it or something to get the answer.
Mm-hmm.
I don't get how you got 15.
Okay. So
I'm kind of confused.
yeah. So something times some. Let's change colors. Something times something equals 144. That was 12.
Okay.
Something times something equals 81. That's 9. Now we know that these two squares, the 144 and the 81, when you add them up, they equal 225, right? 144
Yeah.
plus the 81 is 225.
Mm-hmm.
So we need to think of two numbers that multiply each other equals 225. And 15 times 15, 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Bring down the 0. 1 times 5 is 5. 1 times 1 is 1. 15 times 15 is equal to 225.
Okay. Okay.
Okay. So I used the formula leg 1 squared plus leg 2 squared equals hypotenuse squared. I'm going to try using the other formula now with a squared plus b squared equals c squared. You can use either formula. It doesn't matter. Here's a second problem. So let's choose a different triangle. Could I get a new volunteer to share out what the hypotenuse and lengths are? So I think Milky helped the first one out. Or was it Kelly? I don't remember. Who was that one?
Milky did what?
The first one. Who helped with the first example?
Kelly.
Kelly? Okay. Could I get a new volunteer with the second example? By labeling the hypotenuse and lengths.
Well, I can do it.
Sure, go ahead.
What am I supposed to answer the question mark?
Not answer, just more like which are the hypotenuse and length.
The question mark is the hypothesis because the right angle is on the opposite side of it.
Okay.
And the 5 and the 2 would be the legs.
Good. So the hypotenuse is also known as C, and the legs are also known as A and B. Okay. So with that said, we have to use the formula A squared plus B squared equals to C squared. So we'll draw out the square for one of the legs, and for the other leg, I should change colors. So let's go with, actually use a similar color scheme. So A squared, so we have 2 times 2, which is going to give us 4. And then we have B squared, which is 5 times 5, which equals 25. And then we have C squared, which we don't know yet. So in this case, A squared is 2 squared. B squared is 5 squared equals to C squared. 2 times 2 is 4. 5 times 5 is 25. So 4 plus 25 is equal to 29. Can anyone think of a number multiplied by itself to equal to 29? Is there such a number? So we know 144 is 12 times 12, 81 is 9 times 9, 225 is 15 times 15.
Can it be a decimal?
Can you give me a whole number? So what two numbers multiply by itself to equal to 29? Is there one that exists?
No.
No. You can do 5 times 5. Let me write it somewhere on the side. You can do 5 times 5, but that gives you 25. That doesn't give you 29. You can do 6 times 6. That gives you 36, not 29. So we know the answer is somewhere between 5 and 6, but we don't know exactly where because 29 is in between these two numbers. So to find the answer for the hypotenuse, C squared, you take the square root of C squared, and you take the square root of 29. And your final answer is the square root of 29, because the square root of 29 is somewhere between square root of 25 and square root of 36. Any questions?